We are creating more data today than at any point in human history. But here's the paradox, the really big problem. The more of it we make, the less we seem to trust it. And this isn't just some tech issue for engineers to solve in a back room. No, this is a full-blown crisis of confidence, and it's putting the brakes on innovation. So today, we're going to unpack why this is happening and look at a radical shift in how we think about the very DNA of data itself. And look, the numbers here tell a pretty scary story. You can see data generation is just exploding. We're talking zettabytes, just a mind-boggling amount of information. But at the same time, that red line, our trust in that data is absolutely plummeting. Today, we're at about 38% trust. By 2030, that's forecast to drop to just 18%. Think about that. We are building a universe of information that we fundamentally can't believe in. And this isn't some far-off theoretical problem. It's happening right now. This quote from Bain & Company says it all. Nearly 7 out of 10 companies are already hitting the brakes on new AI projects. Why? Because they can't trust the data that fuels them. The very foundation of this AI revolution is starting to feel shaky, and it's stalling progress before it even gets going. Now, if you want to see this trust crisis in its most extreme, high-stakes form, we have to talk about smart contracts. These are the self-executing agreements written in code. They promise these amazing, automated, irreversible transactions. It's a revolutionary idea, but it's got a catch, a really big one. Here's the fatal flaw. Smart contracts, for all their power, are essentially deaf and blind. They live in this perfect, clean little digital bubble, completely cut off from the outside world. They can't access any real-world information on their own, and that one limitation has basically crippled their adoption for most serious business use cases. So, this leads us to what's famously known as the Oracle problem. To get any real-world data, like a stock price or the weather or a shipping update, the contract has to rely on an external service called an oracle. But here's the thing. The contract has to blindly trust whatever that oracle tells it. There's no way to prove where the data came from, if it's accurate, or if it's been tampered with. It's the ultimate garbage in, garbage out scenario, but with irreversible consequences. There's no undo button. And if that wasn't bad enough, it's compounded by the ambiguity problem. See, the code in a contract is brutally precise. If X happens, then do Y. But the real-world data that's supposed to define X, well, that's often fuzzy, it's messy, it's ill-defined. And this clash between the rigid logic of code and the ambiguous nature of real-world data, it leads to disputes, exploits, and, catastrophic failures. Okay, let's make this super simple. Imagine a smart contract for a big shipment of medicine. It's set up to automatically pay the supplier the second it's delivered. But there's a critical condition. The cargo has to stay below 8 degrees Celsius the entire trip. So the contract needs that temperature data. But how on earth can it get it? And more importantly, how can it possibly trust it? This is where we need a huge mental shift. We need to go from trusting the messenger to trusting the message itself. On the left, you see the old way. The contract gets a random piece of data, temp 5.2, and just has to hope it's true. But on the right, it's completely different. The contract receives a rich, verifiable data asset. It's got the temperature, sure, but it also has the sensor's ID, a precise timestamp, and a cryptographic signature proving it's legit. The contract isn't just trusting the delivery guy anymore, it's verifying the sealed, notarized package. So how do we make this incredible shift possible? How do we get to a place where we can trust the message, not the messenger? Well, it requires a totally new way of thinking. It's about creating data that can speak for itself. Data that has its own proof, its own DNA of trustworthiness, baked right in from the moment it's born. And this is where something called a Semantic Data Contract, or an SDC, comes into play. The best way to think about it is as a locked, permanent, machine-readable blueprint for your data. But it goes way beyond just describing the structure. It formally defines the data's meaning, its context, its business rules, everything. So what you get at the end isn't just a piece of data. You get a verifiable, self-describing asset that simply can't be denied. So how does it actually build that trust? Well, it's basically a 3-part recipe. First, you have the immutable model. This is that permanent lockdown blueprint we talked about. It defines what the data means forever. Second, every piece of data created becomes a verifiable instance of that model, which is digitally signed to prove exactly where it came from and that it hasn't been messed with. And finally, it's self-describing. All the meaning and context travels with the data, so it can always be understood no matter where it goes. So remember our oracle problem? With an SDC, the oracle isn't just shouting a random number into the void anymore. It's delivering a verifiable payload. The smart contract doesn't have to trust blindly. It just checks the digital signature. If it checks out, boom, trust is established. Problem solved. And what about that ambiguity problem? Well, the SDC model itself becomes the smart contract's official schema, its dictionary. There's no more arguing over what temperature or delivery time actually means. The definition is locked, machine-readable, and crystal clear for the code to execute against. No more guessing games. When you put all this together, what SDCs really do is create a bridge of trust. They finally safely connect the messy, unpredictable real world to the clean, rigid world of digital logic. And honestly, this is the missing piece of the puzzle that could finally allow smart contracts to grow up and be used for serious enterprise applications. Okay, so fixing the smart contract paradox is obviously a huge deal. But the core idea here, this concept of an immutable, self-describing blueprint for data, has implications that are so much bigger. It points us toward a future of what you might call permanent data validity. To understand why that's so important, think about one of the biggest, most expensive headaches in all of corporate IT, the endless cycle of data migration. You know what I'm talking about. Every time you upgrade a system, change a vendor, or move to the cloud, you're forced onto this nightmare treadmill of moving data, and you're always losing context and integrity along the way. But what if the meaning of your data wasn't trapped inside an application's database? What if its definition was permanent and the data could describe itself? Well, suddenly, the data becomes independent. It's free. And that entire endless, risky, and unbelievably expensive cycle of data migration, it just goes away. And the payoff here is just transformative. We're talking about permanent data validity, which lets you build enterprise architectures that are actually future-proof. You get true data interoperability between systems. And the big one? Massive long-term cost savings. All of it built on that foundation of verifiable trust that we've been talking about this whole time. So you see, this is so much bigger than just data governance or a new tool. It's a fundamental change in the very nature of our relationship with data. It's about giving data its own voice, its own proof, its own DNA. So the question I want to leave you with is this. If you could absolutely guarantee the meaning of your data forever, what could you build?